There are two methods of resistors no connect karande. So when the resistors are connected in series, current in series connection, total potential in a series connection, battery ਦੇ across ਜਿਹੜਾ potential ਹੋਏਗਾ, this type of connection is known as parallel connection. So total current of the circuit in parallel combination and in parallel combination of resistors. Now let us discuss activity 11.4. Result of this activity 11.5, activity 11. Dear all, I am Jaswinder Singh and today I am going to discuss with you chapter electricity. In today's lecture, I will be discussing with you series and parallel connection of resistors. We will also do some numericals. Let us start the video. There are two methods of joining the resistors together. One is in series and second in parallel. In today's lecture, we will discuss what is series and parallel connection. So what are the values of potential difference and current in series and parallel connections, and what is the equivalent resistance in the two systems of connection. Resistors in series, when the two resistors are connected end to end. So this type of connection is called as series connection. Here in this figure we can see two resistors R1 and R2 are connected end to end. So this type of connection is known as series connection. So in the circuit diagram, three resistors R1, R2, R3 are connected end to end in series connection. In a series connection, each resistor is connected to a different component. So here we can see the resistor R1 is connected on one side to ammeter and on second side to resistor R2. Similarly, the resistor R2 on one side is connected to resistance R1 and on the other side is connected to resistor R3. In the same way, resistor R3 is connected on one side to resistance R2 and on the other side to key. So all the three resistors are connected to different components. This type of connection is known as series connection. How is current affected in series connection? In this circuit diagram, we can see current I is flowing through the ammeter. Through resistor R1, I current is flowing. Through resistor R2, I current is flowing. And through resistor R3, I current is flowing. There is only one path, there is only a single path for current to flow. So the current through resistors is same. Current through resistors connected in series connection is same. So R1 is having current I, R2 is having current I, R3 is having current I. So the current passing through resistors connected in series remains the same. In a series connection, potential through different resistors is different. So we can see the potential through resistance R1 is V1, potential through R2 is V2, potential through R3 is V3. So potential of R1 is V1, potential of R2 is V2, potential of R3 is V3. So the total potential through the battery is V. So V is equal to V1 plus V2 plus V3. Potential of battery is the total potential across the circuit is sum of the individual potentials of different resistors. So V is equal to V1 plus V2 plus V3. So we have seen here in a series connection. So total potential is the sum of the individual potentials while the current remains the same. So we have seen in series connection, potential across different resistors is different while the current remains the same. When the resistors are connected across same terminals, this type of connection is known as parallel connection. When two or more resistors are connected across same terminals, this type of connection is known as parallel connection. So here we can see three resistors R1, R2, R3. They are connected across the same points. So this type of connection is parallel. In the circuit diagram, we can clearly see R1, R2, R3. These three resistance are connected across the same points X and Y, across the same terminals X and Y. So this type of connection is known as parallel connection. So here we can see all the three resistors, they are connected across the same points. Current in parallel connection. Here in the circuit diagram, we can see I current is flowing through here at X. The current is I, and from here current divides into three different paths. There are three different paths for current to move. I1 current moves towards S, I2 current moves towards P, and I3 current moves through L. So we can see here in resistance R1 the current is I1, in resistance R2 the current is I2, and resistance R3 current is I3. So current here at point Y is again I. So I current splits into three currents, I1 plus I2 plus I3. So the current through resistors connected in parallel connection is different. Potential difference in parallel connections, where we can see all the three resistors R1, R2, R3. They are connected across the same points X and Y in the circuit. So the potential difference across X and Y is same as that through R3, R2, R1. So potential remains the same. V is equal to V1 is equal to V2 is equal to V3. The potential across the three resistors connected in parallel connection remains the same. Now let us discuss activity 11.4. So this is the activity to find the current in series combination. What we require? We require three resistors of different value. Like one is of 1 ohm, second 2 ohm, third 3 ohm. So we take three different value resistors, a battery, an ammeter, and a plug key. We arrange all these components as shown in this circuit diagram. Now we switch on the key and note down the reading of ammeter. So let this reading be I1. Now what we do, we replace this ammeter from this position to another position. Suppose here in between R1 and R2. So we note down this reading at other position as I2. Again we replace this ammeter at another position. Suppose this reading is I3, again at some other position. Note down the reading I4. So we change the position of ammeter to different places and note down the readings at various positions. What we observe that I1 equals to I2 equals I3 equals I4. That is, the current remains the same at any part of the circuit when the resistors are connected in series combination. Observation: it is observed that the value of the current in the ammeter is the same independent of its position in electric circuit. The current remains same whether the ammeter is connected between two resistors or anywhere else. So it is independent of the position in the circuit. Result of this activity: in a series combination of resistors, the current is same in every part of the circuit, or the same current flows through each resistor. Activity 11.5, we perform this activity to find potential difference in series combination. Our requirements: we need three resistors of different value, like one is 1 ohm, other 2 ohm and 3 ohm. A battery, voltmeter, ammeter and a plug key. So we connect these three resistors in a series connection as shown in the circuit diagram. First we connect voltmeter across XY and we note down the reading. So this reading is V. Then we connect the voltmeter across the points X and P and we note down the reading. Let this reading of voltmeter is V1. Then we connect this voltmeter between the points Q and S. We note down the reading of voltmeter. Let the reading is now V2. Again, we connect this voltmeter across points P and Y and note down the reading. Let it be V3. So what we observe that V1 is not equal to V2 is not equal to V3. So all the three values we obtained from the voltmeter at different positions is not the same, and this is again not equal to value of V. So it means potential across the resistors connected in series combination is not the same. So what we observe, another observation that we obtain from this activity is when we combine the values of V1, V2, V3, we find it to be equal to V. That is, V is equal to V1 plus V2 plus V3. So total potential across X and Y is equal to sum of the potential across the three resistors R1, R2, R3. Activity 11.6, find total current in the parallel combination. So what we require three resistors of different values R1, R2, R3, a battery, plug key, voltmeter and an ammeter. So we connect these components in a parallel combination as shown in the circuit diagram. So what we do, we note down the reading of ammeter. Suppose this value is I. Now we replace this ammeter at this position. We note down the reading. Let it be I1. Again, we change the position to another position. So we place our ammeter here. Note down the reading. Let it be I2. We change the position of ammeter to another position. Note down the reading of ammeter. Let it be I3. Observation, what we observe? We observe I is not equal to I1 is not equal to I2 is not equal to I3. The readings of various positions of ammeter is not the same. It means the currents does not remain the same throughout the circuit. So on careful observation, what we find, I equal to sum of these values. I equal to sum of I1 plus I2 plus I3. So we find that total current in the circuit remains the same, and at the various resistors connected in parallel, the current get divided through different resistors. The total current in the circuit remains the same. This is all about today's video. I hope you understood all the topics. If anything is not clear or you have any query, you are free to write in comment box. All the queries in the comment box will be addressed. In our next video, I will be discussing equivalent resistance in series connection and equivalent resistance in parallel connection. So don't forget to view that video. Thanks for being with me. Let us revise today's lesson. Resistors in series. An electric circuit in which resistors are joined end to end. The resistors are said to be connected in series. Current in series combination. In a series combination of resistors, the current is same in every part of the circuit or same through each resistor. Potential difference in series combination. Total potential difference across a combination of resistors in series combination is equal to the sum of potential difference across the individual resistors. That is, Vs equals V1 plus V2 plus V3. Resistors are said to be connected in parallel if their terminals are connected to the terminals of same component. Current in parallel combination. The total current in parallel combination is equal to sum of the separate currents through each branch of the combination. That is, Ip equals I1 plus I2 plus I3. Potential difference in parallel combination. The potential difference across the parallel combination is equal to the potential difference across each resistor. This is all about today's lecture. Thanks for being with me.